In this video, we're going to discuss solving quadratic equations using the quadratic formula. When would you use the quadratic formula? There are many different ways to solve quadratic equations for their roots, for their zeros. We've discussed factoring, completing the square, but not all polynomials are factorable, and completing the square only works when a is equal to 1, and it works best when b is an even number. The quadratic formula will always work regardless of any factors, anything. The quadratic formula works for every single polynomial to solve for the roots of any quadratic equation. So if factoring and completing the square don't work, you can try the quadratic formula. The quadratic formula, you are not required to memorize it. It is on the reference sheet that you'll get with your Regents. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And what does this mean? Let's say you have an equation in the form y is equal to ax squared plus bx plus c. Wherever you have an a term in your equation, you're going to plug it into the formula. Wherever you have a b term in the equation, you're going to plug it into the formula by b. Wherever you have a c term in the equation, you're going to plug it into the formula by c. So let's look at that. We have our a term over here. So wherever we see an a in the formula, we're going to plug in an a, whatever our a term is. The same thing for b. Wherever we see a b in the formula, we're going to plug in our b term with this sign. Every term is always connected to its sign. So let's say a would be positive, it would be connected to that positive sign there. And wherever we see a c in the formula, we're going to plug in our c from the equation with its sign. Let's look at an example. Y is equal to x squared minus 4x minus 12. Let's define our a, b, and c terms. A in this case, a is always the coefficient of the x squared term. In this case, x squared has no coefficient, so we assume that it's a 1. B, in this case, b is always the coefficient of the x term, and we take it with its sign, so b is negative 4. And c is the constant term, always. Take it with its sign, so that's negative 12. Let's plug into our formula. X is equal to negative whatever our b is. Our b is negative 4. So negative 4 plus or minus the square root of b, which is negative 4, squared minus 4 times a, which in this case is 1, times c, which in this case is negative 12. And that whole thing is over 2 times a, and a in this case is positive 1. Now all we need to do is simplify this equation to solve for x. Let's do that. X is equal to negative times negative 4 is just positive 4, plus or minus the square root of negative 4 squared is 16. Negative 4 times 1 is negative 4. Negative 4 times negative 12 is positive 48. And the whole thing is over 2 times 1, which is just 2. We need to further simplify this equation. So x is equal to 4 plus or minus the square root of whatever 16 plus 48 is. 16 plus 48 is 64. Over 2. Let's keep on going. So x is equal to 4 plus or minus the square root of 64 over 2. The square root of 64 is 8. So x is equal to 4 plus or minus 8 over 2. So let's break this up into two different equations. We either have x is equal to 4 plus 8 over 2, and we also have x is equal to 4 minus 8 over 2. 4 plus 8 over 2. 4 plus 8 is 12. 12 over 2 is 6. And then our other solution for x is x is equal to 4 minus 8, which is negative 4, over 2, which is negative 2. So the two solutions of this quadratic equation are x is equal to 6 and x is equal to negative 2, which means that this graph crosses the x-axis. It has roots at x is equal to negative 2 and at x is equal to 6. Let's see if that's true. We can graph it on the calculator. Let's go back to our equation, and we'll graph it in y1. So y is equal to 1x squared, or just x squared, minus 4x, minus 12, and we're going to graph it in zoom standard, so zoom 6. And if you would count, you would see that this graph crosses the x-axis at x is equal to negative 2 and at x is equal to positive 6, which is what we found when we solved this equation using the quadratic formula. Let's look at another example. Y is equal to 8x squared minus 6x minus 19. And we want to use the quadratic formula to solve this. Quadratic formula is, you don't need to memorize it, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Let's just define what our a, b, and c terms are for this specific equation. A is always the coefficient of the x squared term. So a is equal to 8, and wherever we see an a in our formula, we're going to plug in 8. B, in this case, is negative 6, because b is always the coefficient of the x term. Wherever we see a b in our formula, we're going to plug in the b from our equation, which is negative 6. We always take a value with its sign. And then the last term that we have is c. C is always the constant, and we always take it with its sign. C is negative 19. Wherever we see a c in our equation, we're going to plug in negative 19. So let's do it. X is equal to negative, whatever b is, b in this case is negative 6, plus or minus b, which is negative 6, squared, minus 4, times a, which in this case is 8, times c, which in this case is negative 19, and that whole thing is over 2 times a, which in this case is 8. So let's simplify this. X is equal to negative times negative 6 is positive 6, plus or minus the square root of negative 6 squared is 36. Negative 4 times 8 times negative 19, let's just punch the whole thing into the calculator. Negative 4 times 8 times negative 19 is 608. So we have 36 plus 608 in the square root over 2 times 8, which is 16. Let's simplify this further. X is equal to 6 plus or minus the square root of 36 plus 608, which is 644 over 16. Let's see, is the square root of 644, is that a perfect square? It is not, so we're going to have to put it into simplest radical form. To do that, we need to find the prime factorization of 644. We're going to find the smallest number. If you don't remember this, you can go look back on the videos on simplifying radicals. We need to find the smallest number that 644 is divisible by that's greater than 1. That is 2. 644 divided by 2 is 322. We need to find the smallest number that 322 is divisible by that's not 1. And that's 2. 322 divided by 2 is 161. 161 is a prime number. The only numbers that go into it are 1 and 161. So our prime factorization is 2, 2, 161. We take our doubles, which in this case are 2. We bring out one of our doubles, and we leave the single inside. 161. So let's just write over the whole equation. 6 plus or minus 2 square root 161 over 16. Can we simplify this? Let's try. We could rewrite this as 6 over 16 plus or minus 2 square root 161 over 16. And this we can rewrite 6 over 16, that can be reduced. 6 and 16 are both divisible by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. And this is 3 over 8 plus or minus 2 square root 161 over 16. That can be reduced also because 2 square root 161 and 60 are both divisible by 2. 2 square root 161 divided by 2 is square root 161. And 16 divided by 2 is just 8. Since they have the same denominator, we can put them back together again. So 3 plus or minus square root 161 over 8 would be our two roots. Our two roots are really 3 plus square root 161 over 8 and 3 minus square root 161 over 8. But you can leave it like this and just realize that this is really two roots. Let's look at one last example. Y is equal to x squared minus 8x plus 16. And we're going to solve this using the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Wherever we see an a in our formula, we're going to plug in the a from our equation, which in this case is 1. Wherever we see a b in our formula, we're going to plug in the b from our equation, which in this case is negative 8, because every number always comes with a sign before it. And wherever we see a c, which in this case is over here, in this case it's positive 16, we're going to plug in positive 16. So let's do that. X is equal to negative b, which in this case is negative 8, plus or minus the square root of b, which is negative 8, squared, minus 4 times a, which in this case is 1, times c, which in this case is positive 16. That whole thing is over 2 times a, which in this case is 1. Let's simplify. X is equal to negative times negative 8 is positive 8 plus or minus the square root of negative 8 squared is 64, minus 4 times 1 times positive 16 is negative 64, over 2 times 1 is 2. Let's simplify this. X is equal to 8 plus or minus 64 minus 64 is 0. The square root of 0 is just 0. So this whole thing is just going to fall out. Plus or minus 0 is going to fall out. We're left with x is equal to 8 over 2, or x is equal to 4. How could it be that we have a quadratic function and it only crosses at one point? Most quadratic functions cross at 2 points like this. Cross the x-axis at 2 points, they have two x-intercepts. This is called a double root. A double root occurs when the graph crosses the x-axis, it just touches the x-axis at one point. This is called a double root, and this graph would cross the x-axis at just at x is equal to 4. Let's graph it and see how that would look. Into y equals, we're going to type the equation. Y is equal to 1x squared, or just x squared, minus 8x plus 16, and zoom 6 for zoom standard. And you'll see from the graph on the calculator that this graph crosses the x-axis at just one point, only at x is equal to 4. It only has one x-intercept.